In the vast, silent expanse of space, something impossible is happening. A planet, a rogue world, drifting alone through the cosmic dark, is doing something no planet should ever do. It's acting like a star. Recently, astronomers using the James Webb Space Telescope, JWST, and the Very Large Telescope, VLT, in Chile captured data that left the scientific world speechless. They discovered a runaway planet, a free-floating giant, not bound to any star, that is swallowing 6 billion tons of gas and dust every single second. To put that in perspective, that's roughly the mass of 10 Earths every hour. But how can a planet, something that doesn't generate light or heat like a star, consume material at this rate? This discovery is rewriting what we thought we knew about how planets, and even stars, behave. It started as a feint, a flickering point of light recorded almost accidentally by the Webb telescope during a deep field observation. Scientists noticed that this object wasn't where it was supposed to be. It wasn't orbiting any star, and its motion didn't fit into any known planetary system. Follow-up observations by the VLT's infrared sensors revealed something shocking: a disk of glowing material spiraling into the object, just like the accretion disks seen around newborn stars. The temperature, brightness, and energy patterns were all wrong for a normal planet. Yet it wasn't massive enough to be called a star. Astronomers began to realize they were looking at a completely new category of celestial body, something between a planet and a star. A cosmic hybrid, defying every rule. They named it, unofficially, Runaway XJ0823. Normally, stars form from enormous clouds of gas collapsing under their own gravity. When the core becomes hot and dense enough, nuclear fusion begins. Hydrogen atoms fuse into helium, releasing vast energy, and a star is born. Planets, on the other hand, form afterward from leftover dust orbiting around the new star. They never achieve fusion, and they don't shine by their own light. But Runaway XJ0823 breaks that order entirely. It appears to have escaped its original star system millions of years ago, wandering alone through the void. Somewhere along its journey, it began pulling in interstellar material, hydrogen, dust, and even fragments of smaller bodies, at a rate far beyond anything ever recorded for a free-floating planet. Webb's infrared imaging showed streams of hot gas spiraling into its magnetic poles. The planet's magnetic field seems unusually powerful, about 10 times stronger than Jupiter's. As this material falls in, it heats up and emits light, giving the planet an eerie, star-like glow visible even from billions of kilometers away. This is why scientists say it's behaving like a star, but it isn't one. The measurements stunned even veteran astronomers. The accretion rate, how much material it's drawing in, is roughly 6 billion tons per second. That's enough to fill the Grand Canyon every second, or consume the entire planet Earth in just a few hours. No known mechanism should allow a planet to feed at this rate. It's as if Runaway XJ0823 found a way to cheat cosmic physics, turning itself into a miniature, hungry furnace. Astrophysicist Dr. Lucia Martez of the European Southern Observatory described it like this: it's like watching a planet pretending to be a star. It's pulling in everything around it, glowing in the process. Yet it lacks the mass to ignite true fusion. It's a cosmic paradox. Some researchers think this might be a rare, transitional stage. A moment where a massive gas planet teeters on the edge of becoming a failed star, known as a brown dwarf. Brown dwarfs are sometimes called failed stars because they're too small to sustain nuclear fusion, but too large to be ordinary planets. They glow faintly from the heat of their formation, gradually cooling over billions of years, but XJ0823 doesn't fit even that model perfectly. It's much more dynamic, showing strong magnetic storms, violent bursts of energy, and even variable light patterns, almost like it's pulsating. Others propose an even stranger theory. Perhaps this planet is the core remnant of a dead star, a stripped-down fusion relic that somehow stabilized before collapsing completely. If true, It would be the first known object of its kind. A planetary zombie, reborn in the dark. Could it be growing into a star? One of the biggest questions is whether XJO-823 is on its way to becoming a true star. If it keeps consuming matter at this rate, it could eventually reach the critical mass needed to ignite hydrogen fusion. Around 80 times the mass of Jupiter, that would make it one of the first known. Planets too naturally evolve into a star-like object, flipping our entire understanding of stellar evolution on its head. Dr. Paul Henderson from NASA's Goddard Space Flight Center put it simply: if this object keeps eating, it might one day switch on. Like a cosmic light bulb that's been charging in the dark for millions of years. Imagine that, a rogue planet, wandering alone, feeding on the universe until it becomes a star. But how can this be happening? Scientists think the key might lie in magnetohydrodynamics, the interaction of magnetic fields and charged particles in plasma. If XJO-823 has an unusually strong magnetic field, it could be channeling interstellar gas into tight spiral streams, accelerating the inflow dramatically. This process would heat the material as it crashes toward the surface, releasing massive amounts of energy, enough to make it shine faintly in the infrared. It's like a natural gravitational engine, powered not by fusion, but by constant accretion. Another explanation is that XJO-823 may have passed through a dense molecular cloud, a region rich in hydrogen. As it plows through the gas, its gravity sucks in material like a cosmic vacuum cleaner. This could temporarily create the illusion of a star-like feeding frenzy, a runaway phase that will eventually slow down once it leaves the cloud. Still, none of this explains how it maintains such a powerful magnetic field, or how it has survived for so long without breaking apart. For astronomers, this discovery is more than just a curiosity. It could unlock new clues about how stars, planets, and rogue worlds evolve in the chaotic dance of galaxies. Until now, we believed planets were passive, lifeless orbs depending entirely on their parent stars. But Runaway XJO-823 challenges that belief. It's proof that planets, too, can change, grow, and maybe even ignite. As one astronomer said during a conference at the European Space Agency, the universe doesn't like rules. Every time we think we understand it, it throws us a runaway planet. The discovery of XJO-823 could redefine the boundaries between stars and planets, revealing that cosmic evolution is far more fluid and unpredictable than we ever imagined. But the mystery doesn't end there, because new data from the Webb telescope shows something even stranger. This runaway planet might not be alone. When the James Webb telescope sent its follow-up data back to Earth, the entire astronomy team was expecting confirmation of what they had already seen. One bizarre planet behaving like a star, but what they found instead was far more unsettling. Scientists are calling this region the feeding field. It's an invisible hunting ground in deep space, where planets devour gas and dust like cosmic predators. Using combined data from Webb, the Atacama Large Millimeter Array ALMA, and the Very Large Telescope, astronomers mapped the infrared emissions in this field. The results were astonishing. Each of these objects was releasing steady thermal radiation, consistent with accretion, not reflection. That means they weren't just glowing from starlight. They were producing their own heat. The discovery raised a terrifying possibility. Perhaps these planets aren't rare accidents. Perhaps this is a natural phase of rogue planet evolution. If free-floating planets can generate magnetic fields powerful enough to pull in interstellar material, they might wake up, periodically feeding like newborn stars before cooling back down into silence. Dr. Naomi Feldman of the European Southern Observatory described it beautifully. It's as if these worlds are asleep for eons, and then suddenly they feed. They come alive for a moment, burning with stolen light, and then they vanish again. How did XJO-823 and its siblings become runaway planets in the first place? The leading theory points toward gravitational ejection. In the violent early days of star systems, when planets are still forming, gravitational battles are common. A giant planet can be slingshotted away from its parent, star during close encounters with other massive bodies. Most of these ejected worlds drift forever in the cold void, freezing and forgotten. But a few, perhaps the most massive ones, might ignite something deep inside. If a planet is large enough, with a metallic hydrogen core and an intense magnetic field, it could start to behave differently once it's free from its star. Instead of dying, it might begin to feed. This would make XJO-823 the first known self-sustaining runaway planet, not dead, not alive, but existing in a strange twilight between both. Observations in near-infrared wavelengths revealed an even deeper mystery. The glow surrounding XJO-823 isn't uniform. It pulses, rhythmically, every 12 hours. That means something inside this planet is beating like a cosmic heartbeat. At first, scientists thought it might be rotational, the planet spinning rapidly, exposing brighter and dimmer regions. But later models showed the pulse wasn't caused by rotation at all. It was energy release. Every few hours, the accretion rate spikes, then drops, as though the planet inhales and exhales. Some researchers suggest it's caused by magnetic reconnection events, bursts of plasma energy, similar to solar flares, but on a planetary scale. If true, this would be the first time in history that a planet has shown star-like magnetic eruptions. It's not just feeding like a star, it's behaving like one. So how is XJO-823 generating such power without fusion? The answer might lie in magnetohydrodynamic turbulence, a phenomenon where conducting fluids, like metallic hydrogen, create self-sustaining magnetic fields. In Jupiter, this effect drives its massive auroras. But in XJO-823, the effect seems supercharged. Its core may be rotating at tens of kilometers per second, amplifying its magnetic field to extreme levels. This field, in turn, captures surrounding plasma and channels it toward the poles, creating bright, glowing jets of matter that shoot out into space. Webb captured faint traces of these polar jets, narrow beams of energy extending millions of kilometers, just like those seen in young stellar objects. That's when astronomers realized this planet isn't just mimicking a star, it's rehearsing for it. The accretion rate suggests that within the next few million years, XJO-823 could double or even triple its current mass. If it crosses the critical threshold of 80 Jupiter masses, hydrogen fusion will begin. At that point, the planet would ignite, becoming a true red dwarf star. That transformation would make it the first planet known to naturally evolve into a star, an event never observed before in the cosmos. Dr. Andrew Clark from the University of Cambridge explained it this way: "We've always assumed stars die and leave behind planets. But maybe sometimes it works in reverse. Planets die, and from their death, a new star is born." It's a poetic, terrifying idea. The cycle of creation flowing backward. The smallest worlds giving birth to the light of new suns. Could it threaten solar system? Some experts have begun to wonder, what if such runaway planets exist closer than we think? The Milky Way could contain billions of free-floating planets, ejected from their home systems. Most are dark, invisible, and harmless. But if even a few of them can enter this feeding phase, they could briefly shine, or even alter nearby systems through gravitational effects. If one such object ever passed near our solar system, the consequences could be dramatic. Its gravity could disturb the Oort cloud, the vast halo of icy bodies surrounding our sun, sending comets hurtling inward. Worse, if it entered the inner system, it could destabilize planetary orbits or strip away atmospheres through radiation bursts. Fortunately, there's no evidence that any runaway planet is anywhere near us. But the idea that the galaxy hides feeding worlds, silently growing in the dark, has added a new kind of unease to the field of astrophysics. Beyond the science, the discovery of XJO-823 has also sparked deep philosophical questions. What exactly defines a planet? If a world can live, feed, and one day ignite, does that make it a form of cosmic life? Can we still call it a planet? Or is it something entirely new? A protostar organism of the universe? Dr. Lin Tao from MIT explained. Perhaps the universe itself has layers of life. Stars live and die. Galaxies breathe. And now we see that even planets might feed. Maybe the boundary between life and physics isn't as strict as we thought. The discovery has triggered a global search for more such objects. Webb's Next Generation Survey, scheduled for 2026, aims to scan the nearby Taurus molecular cloud, where scientists suspect other runaway accretors may be hiding. If they find more, it could mean that these feeding phases are common, a normal, though temporary, part of cosmic evolution. Meanwhile, computer simulations suggest that under the right conditions, any massive gas planet could become a runaway accretor. If it drifts through a dense enough region of space, this means that across our galaxy, maybe even in intergalactic space, there could be thousands of star seeds, silently feeding, preparing for ignition. The line between planet and star, once so clear, is now dissolving. In the words of Elizabeth Howell, the science journalist who broke the story, the cosmos doesn't care about our definitions. It just keeps creating, destroying, and blurring the boundaries we invent. Runaway XJ0823 reminds us that the universe is not static. It's alive with transformation. Every star, every planet, every dust particle participates in an eternal process of becoming something new. Maybe, one day, long after humanity is gone, these rogue worlds will have finished their transformation, small, glowing stars wandering between galaxies, carrying with them the story of how a planet dared to become a sun. In one of the final observation sessions, Webb's instruments picked up an unusual pattern, a sudden, intense burst of infrared light from XJ0823. For nearly 20 minutes, the object's brightness tripled before returning to normal. No known mechanism could fully explain the event. Some think it was a massive accretion surge. Others think the planet's outer layers might have collapsed inward, releasing stored gravitational energy. Whatever it was, that single pulse lit up the surrounding nebula, a brief, ghostly illumination that traveled across space and time. For a moment, the darkness around XJ0823 wasn't empty. It was alive. And then, silence again. The runaway planet went dark, fading back into anonymity. But humanity had already seen it and recorded the impossible. For the first time, we had witnessed a planet becoming something more.